Okay, complex fractions. Do you like fractions inside of fractions? Yeah, so anyway, mathematicians don't like them, so we're going to learn two different methods that we can use to make these fractions inside of fractions into regular fractions. Have you seen Inception? Inception is a movie where they go into people's dreams, but then sometimes inside the dreams, they fall asleep again and go into a dream within a dream, and then sometimes within that dream they even go into another dream. If you haven't seen the movie, you really need to see it. Every time I think about fractions inside of fractions, I think about Inception. Anyway, here's a fraction inside of a fraction. This is it. If you notice, we have fractions in the numerator and we have fractions in the denominator of this really big fraction. So it's really, really complicated, and mathematicians hate these because it's way too complicated. Luckily, there are some techniques for simplifying these. Instead of showing you two different examples, I'm going to show you the same example, but I'm going to show you two different methods of doing it. Just so you know, the first method is, I think, the one that previous students have liked more. Method 2 is the one that I like more, though, and the one that I think you'll find more useful down the road. Anyway, I will show them both to you, and you can kind of pick a method you like and become an expert at it, or become an expert at both methods, knowing that both may help you in different situations. So method 1 is this. I have a fraction over a fraction, but I know that this fraction bar can be treated like division. So method 1 says, hey, I just learned how to subtract these two into one fraction. On the bottom, I already have one fraction. So let's get a fraction on top and a fraction on the bottom and then just divide them, because I also know how to do that, okay? So first, we're going to start by combining the two fractions on the top. We're going to put these two together. So let's just ignore the bottom fraction for now, and we're going to ignore the fact that these two fractions are actually inside of one big fraction, and we're just going to worry about subtracting them. Now, you know the first step in subtracting here is we are going to factor the denominators, because I need to get a least common denominator as always, but in order to do so, it would really help to factor. The first denominator can't be factored. The second denominator I can pull out of 4. And so we see now that, yeah, each of these fractions has 2x minus 5 in the denominator. All I need to do is multiply this first fraction by 4 over 4. That will give me the least common denominator that I need. So now I do have the least common denominator, and I am set to subtract these fractions. And notice I'm leaving a gap at the bottom here because, yeah, there is actually a fraction down there. Anyway, the point is, when I subtract these two fractions, I'll get negative 3, subtract the numerators, over 4 times 2x minus 5, leave the denominator the same. And that is now one fraction on top of my really big fraction. But of course, on the bottom, I still have this x over 2x minus 5. This has just been kind of hanging out here the whole time. X over 2x minus 5. Okay, so now I have this. Instead of multiple fractions over a fraction, I have just one fraction over just one fraction. And here's the point where I'm going to say, hey, let's actually look at this fraction bar and think of it like division. So now I'm going to write it horizontally. On top, I have negative 3 over 4 times 2x minus 5, divided by, because this fraction bar can be thought of like dividing, x over 2x minus 5. Okay. But we know that dividing is the exact same thing as multiplying by the reciprocal. So I'm going to flip this second fraction. I'm going to reciprocate it. And, coughing. Oh, yes. Complex fractions are painful things. Okay, so at this point, so I thought of this fraction bar like dividing, but I know that dividing is the same as multiplying by the opposite. And now that I'm multiplying, I can start pre-reducing some things, right? And in fact, I see that there's a 2x minus 5 on the top and a 2x minus 5 on the bottom. That leaves me with just a negative 3 on top and just 4 times x on the bottom. Wow. So as it turns out, this whole thing actually, after I combine the top into just one fraction and then think of it like dividing, it actually cancels to just -3 over 4x. Very cool. Okay, so that's method 1. Get the fractions on top together, think about it like dividing, use the rules we already knew how to do. Here is method 2, and again, this method is something that I think works better when you get up to maths like calculus, this line of reasoning. This line of reasoning is going to rely more on the LCD and then multiplying by a tricky fraction, so like something over something that actually equals 1, and I'll show you what I mean. I still need to find the LCD of each denominator, but this time I'm going to include this denominator and this denominator and this denominator, okay? So let's factor all of these denominators. So on top, we know there's no factoring. On top of the second fraction, I know factors to 4 times 2x minus 5, pulling out the GCF. Bottom, I have this 2x minus 5. I want to find the LCD of all 3 of these fractions. What's the LCD of all 3 of these fractions? And it looks very clear that the LCD here is definitely going to need to include the 2x minus 5 because all 3 of the denominators have that. Also, it needs to include the 4 that only this fraction's denominator has. So here's my LCD. So far I haven't done anything too crazy different, except I'm including this fraction's denominator as well, because here's what I'm going to do. I'm going to multiply this entire big fraction by something over something that's the same that equals 1. And I'm going to do so in such a way that's going to cancel all the denominators, and what I'm going to multiply by is the LCD. So take a look at what's happening here, and then you'll see what's happening. I'm going to multiply by the LCD, and it oftentimes helps to think of it as like the LCD over 1, because when we multiply by this LCD, we want it to be going to the top of all the different fractions. So just bear with me. All that I'm doing here is I'm multiplying by the LCD over the LCD. I'm multiplying it times the big fraction. I am allowed to do this mathematically because I'm just multiplying here by the same thing over itself, which is 1. So it keeps the problem the same. So here's what ends up happening. On the top, remember, it's top times top, bottom times bottom. So this is going to distribute to this fraction and this fraction on the top. And my pen is getting worse, which is sad. Oh, it's not making perfect lines like it used to. Okay, anyway, so I'm distributing this LCD both to the first fraction and the second fraction on the top because I have distribution going on. So let's take a look at what happens when I distribute it to the first fraction. I have 1 over 2x minus 5 times 4 times 2x minus 5 over 1. And I know that that is going to pre-reduce. All that I'm left with is 4. Kind of neat. Now let's do it with the second fraction. I have negative 7 over 4 times 2x minus 5 times 4 times 2x minus 5 over 1. So now I'm taking care of this fraction times this fraction. All right, this distribution, I actually pre-reduce, leaving me with just the negative 7. So I have negative 7 now on top. Okay, so that's the top. Next, on the bottom, this fraction, this whole fraction distributes to that whole fraction. So I have x, oh, my pen, it's sucking today, x over 2x minus 5 times, 2x minus 5 and 4 over 1. Okay, I pre-reduce, which leaves nothing on the bottom, so I just have 4x. Notice what happened here. Since I multiplied by the LCD, are there any fractions left once I distribute that in? And the answer is no. Multiplying by the LCD always cancels the denominators. So that's why this is a very effective method. Since I multiplied by the LCD, I've now canceled all the denominators, and I'm left with just simple things on the top and the bottom. So multiplying by the LCD, it cancels the denominators. All I have to do now, what's 4 minus 7? Well, of course, negative 3 over 4x. And I'm done. Whew. Okay, so method number 2, I look at all of the denominators. I find the LCD. I multiply the big fraction by the LCD over itself. That will cancel all of the least common denominators, all of the denominators when I distribute it in, and I'll be left with now a fraction that's no longer a complex fraction. Notice I got the same answer here that I got over here, which proves that both methods are valid. Okay, so summary, method 1. This is the one that I think people like better. It's a little bit easier both to describe and to carry out. Just combine the numerator or the denominator into one fraction, okay? So I added the numerator fractions up and got one fraction on top. Then treat it like division, and we're really good at doing it with division. Method 2. Knock out the denominators, just get rid of them. The way you do that is by multiplying the entire big fraction by the LCD. That will knock out the denominators. I know this video was complicated. This is tricky problems. It'll take up a lot of paper, but I think my explanations were pretty good as per the usual. So hopefully that was helpful for you. See ya.